Okay, so we have our part 3 circuit. And so this looks at differing numbers of connectors and extension cords. And so here we have our power box, of course, and I have banana jacks to an extension cord connection, just a normal cord connection to simulate one extension cord connection, very short length, maybe less than 6 feet. So when we talk about voltage drop, in the single digit feet, it's pretty marginal. It has a resistance, but it's marginal. We're talking about the voltages of 120 or 240 or 480. And so then we have our other end, right, going into our light bulb. So this is simulating one connection that you would have for one extension cord. And we're going to have measurements of the box, the source voltage, and then the load voltage at the light. And we'll see the differences. And then we're going to add different numbers and lengths extension cords. Of course, after that blinding light subsides slightly, we have a voltage at our box, or our total voltage at the source, of 121.5. So we have a total source voltage of 121.5. Again, try to do this like this. We'll drop that down to 0.4, round that to 4. So that's our load voltage, sorry, our source voltage. And then if we move our voltage leads to the load, so now we're measuring across the light bulb at the load, we're measuring 121.1. Okay, so not a significant difference. Of course, we only have one connection. Very minimal amount of actual length of conductor. And of course, it is a difference, right? So we can see that there is less voltage at the load now than at the source from the source, but it's a marginal. So now we'll plug in a 50-foot extension cord. So we will in essence put in line here. But now we have a 50-foot extension cord we're going to add to the circuit. So we'll add in this 50-foot here. So again, we'll take this, turn the power off, unplug, and we'll now add in my 50-foot extension cord. Back on. And so now with my 50-foot extension cord, I have a voltage of 120.5. 120.5 volts. Okay. So slowly going down. We are now, of course, at 121.1 with one connection, and now I have a 50-foot extension cord, and I'm at 120.5. So now I have 1, 2, 3, 4 connections, right? And now what we'll do is we'll add yet another 50-foot, so we'll have a full 100-foot. So we'll do that in line here. Turn it off. And so we'll add another 50-foot. So now we have a total of 100 feet. So twice our length. And so of course we have our 250s in series. We have a total of 100. And I'm down to now 119.9. So at a 50 plus a 50, my load voltage is 119.9. Again, that progressive dropping. And then what we'll do is we'll look at what if we added another extension cord. So now we have 3, but this extension cord now is a 100 foot. So I'm doubling again, but I'm only going to have 2 additional connections, right? And so I have where with 2 50 foots, I have 4 connections, right? I'm going to have another 100 feet, but with only 2 connections. So now this is looking at the comparison between the number of connections versus the length of conductor. What is the big ticket item that causes that voltage drop to increase the most? And so we'll add in that. And so here we will say, again, in series, so we'll add all this in series. So now I have 100, 50, and 50. So I have load voltages now at my light, and we will be looking at the load voltage with 50 plus 50 plus 100 feet. So each of these have 2 connections, 2 connections, 2 connections, 2 connections, 2 connections, 2 connections. This now is 4 connections, right? So that's the difference that we're seeing for connectors. So let's power this on. And we have a voltage at the load of 118.8. So now we have a load voltage of 118.8 volts with 200 feet of length of conductor and 6 total connections. So the total number of connections, 6, everything. So now we can kind of reflect back on how we added the circuit elements, as how we added the connections of the extension cords. And we have our total 3 extension cords here, all wired in series. So we have 200 feet length. And of course, we have 6 connections, not counting the initial connection here. So really, we have 8 connections. But for extension cord, we have an additional 6. So now I want to do one last thing. So of course, we've just taken these measurements here. And if we recall, our initial was this. So let's look at with only one 100-foot connection. So that will be a single 100-foot connection in the circuit. We have 120 even, right? So with only 2 connections, we have 120 volts. Whereas when we had this scenario here, which we still had the same 100-foot length, but we had 4 connections, very, very similar, right? Versus what we have now. So I think the difference is a 1/10 of a volt, right? Half a 1/10 of a volt, right, per connection in theory. So that's kind of the significance of the connections. We've halved the connections, so we have half as many connections here versus half as much conductor. Okay, so that's the one comparison I want us to see here. With half the length of conductor, with only 100 feet, we have 120 volts, versus 200 feet, we have 118 volts. With half of the connections, right, we have 4 connections here, versus now we only have 2 connections. Okay, so it looks like that the length of the conductor is really the thing that's governing, or the main significant piece of voltage drop. Conductor length, right, is a big thing. Primary driver. The number of connections have a bearing on that. If you envision a hydraulic system, when you have a valve, you can have some reduction in pressure through the valve, similar to electrical system. But for electrical system, really the length is the key driver. So just to wrap up here, here's where we started. Source voltage, 121.4 out of our box, with just a very, very short connection to the load. One short, very short, less than 6 foot connection. We had a 121.1 volts. Then when we had a 50-foot extension cord, we had a voltage at the load of 120.5. Right? Then with two 50-foot extension cords, 119.9 volts. And then with 3 extension cords, 250s and a 100, we had 118.8 volts. The big difference here was the number of connectors. 2 connectors per cord, right? So over here we have 6 total connectors. Here we have 4 total connectors. And the real driver here wasn't the number of connectors, but was the length of wire. We have double the length here. A total of 200 feet all the way at the far right. We have 100 feet here and 50 feet here. So these will be the measurements we can use as we solve and fill out the table for this part 3 of the lab.